All you cool cats, I am going to do some problems from your homework, so that you guys won't be as confused. All right, I'll do one of the first problems and then one of these, but we did do one in class, and I just kind of want to reiterate that. All right, so look back at that one if you're still confused. And of course, as always, just reach out if you have any questions. Okay. All right. So let's take a look at number one. It says to state the intervals on which the function is continuous. So basically, what we're looking for is everything that's not that doesn't have like a discontinuity in it, right? So for this one, just like a book, I would read the graph from left to right. Okay. So I'm gonna highlight this first part. Right. It looks like that. And since we're just stating the interval, that just means like what x values does the function exist on, right? So this arrow tells me that I'm coming from negative infinity, and which we don't touch, and then we go up until this point right here, which looks like -3. So it's from negative infinity to -3. And I'm not going to include -3 because -3 is not continuous. Okay, so that's my first piece. Let me get the next piece. I'll do it in a different color. Let's say red. So the next piece starts at 3. So it looks like, I'm sorry, at -3. Once again, I'm not going to include -3 because -3 is discontinuous by our definition, right? So we start at -3, and then we go all the way up until, boom, I see a hole at 1. So that's my next interval, okay? And then I just keep going and on and on like that, right? I'm going to pick a different color for the next section. So from 1, I'm not going to include 1, up until well, this one kind of like shoots up and doesn't touch 3. So it looks like from 1 to 3, that's my next interval. And then the very last interval is from 3, right? Because it gets really, really super close to x equals 3. It goes down to infinity, and it goes all the way to the right. So all the way out to infinity. So as you can see, there are 4 intervals where the function is continuous. Okay, if you just leave it like that, that's fine. If you want to do the special U symbol, you can, where it would look like negative infinity to -3, union, -3 to 1, union, 1 to 3, running out of room, union, 3 to infinity. If you want to write it like this, you absolutely can too. But honestly, this is fine for problems 1 and 2. Okay, so I'll leave 2 to you. Moving on. Gonna erase all that. Okay, moving on. I'll do one of these here now, right? So this is a problem that we kind of did in class. I'll do one of these. I'll do number 7. All right. So this is a problem that we did in class, and what we're doing is we're checking for continuity at the breakpoint. And in this case, the breakpoint's at 4, right? It's where the one function ends and the other one begins, right? So if I were to like write this out at 4, okay, to the left of 4 is like, I don't know where this function is, but like if it was there, right, it would look like that. And then to the right of 4, it would look like that, something like that. I don't know. And this one's referring to the top one, I mean the left one, and this one's referring to the right one. Are these functions actually at those heights? I don't know. I don't really know what the graph looks like. I don't really care. All I want to know is at 4, will the two functions kind of be on top of each other? Meaning, will they both have the same y value, like after you plug in 4? So, let's do this. I'll label this 1 and I'll label this 2. So what I'm going to do is plug x equal 4 into 1. I don't know why I wrote the 1 first. Sorry about that. All right, so the first thing I'm going to do is plug x equals 4 into 1, and that will tell me the height of the left function. So I get 5 over 4 plus 4, which is 5 over 8. So that means the left function is at a height of 5 over 8. And we got to see if the other one is going to be 5 over 8. If it's not 5 over 8, that means the function has a break in it, right? So let me erase that for a second so we get a better picture here. So here we go. I'm going to now plug x equals 4 into the second equation. I get 3 minus square root of 4 all over 9 minus 4. And this is 3 minus 2, which is 1, and 9 minus 4, which is 5. So this one's at 1/5, so it's like somewhere like here, and it does its thing to the right. And now we can clearly see that this is a jump discontinuity. So we can say the limit... I guess since the directions ask for the left and right limit, so the limit as x approaches 4 from the left, which is equation 1 essentially, right? This is talking about like case 1, or the first equation up there, right? So of the function is going to be, we said it's 5/8. The limit as x approaches 4 from the right of the same function is, we said it was 1/5. And since these two are not the same, we can say f of x is discontinuous at x equals 4. I think the second or the third part of the equation, or these problems say to like take this to go to infinity and negative infinity. So what that means is just, I'll do it in red. It just means the limit as x goes to infinity of f of x. So infinity means to the right, right? To the right essentially, which means we're looking at this guy. So those infinity tricks that we learned before are going to come into play here, right? For instance, this one, it looks like the power is smaller on top than on bottom, right? Because root x is like 1/2 and then x is... So that means this one is actually going to go to 0 because it's bigger on the bottom as we go to the right. If we go to the left... I'll do this one in blue, right? Limit as x goes to negative infinity of f of x. That means I'm going to plug in a really, really big number for this one because this is the one that goes to the left. Oops. Okay, so in this case, it's much bigger on bottom because 5 just stays 5. So this one actually, oh, look at that. They actually both go to 0. So that was a little anticlimactic, but yeah. So that's the left-hand... that's when you go to negative infinity. The red is when you go to the right, positive infinity. And then the black is, whatchamacallit, the break point. We're looking at the break point to see continuity. All right, so this is what you're going to do for these set of problems. All right, please reach out if you have questions, and have a wonderful, wonderful weekend.